722, how can I find the midpoints? More coordinate geometry, and there's a nice trick to finding the midpoint or endpoints of a line segment, so we'll kind of go through that. So again, I had to kind of jot some of these notes down, and I'm going to go into a coordinate plane and solve it and kind of go from there. So it says triangle midsegments. As Sergio was analyzing polygons, he drew a line segment that connected the midpoints of two sides of a triangle. This is called the midsegment. So DE is the midsegment. He said, I wonder what we can find out about this midsegment. Examining the drawing at right, DE is the midsegment of ABC. Examine the diagram, and how do you think DE is related to AC? Well, usually people say they're parallel, so that's one thing. We're going to see if they're parallel. The other thing that we're going to check to see, and sometimes people come up with this, if I double DE, will it equal AC? So again, is 2 DEs equal to 1 AC? So that's what we're going to do. 794 is going to actually ask us to go plot these points on graph paper. With your team, we're going to figure out what the coordinates are of the midpoints of D and E, so we'll figure those out. Then we'll look at the relationship. We'll see if they are parallel and if the midsegment is half as much as the side. And then we will calculate the perimeter of the triangles and compare them, and we will calculate the areas of the triangle and compare them. So again, I have these notes jotted down. So we will go over here and open these up and see what we come up with. So on this one, I want the regular coordinate plane, I believe. So A was 0.00. B was 2,6. And C was 7,0. I guess I should be marking this down. I'll get my straight line tool and I will complete this. So the question would be, it didn't go well right there. I don't know if that helps, but whatever. The question would be, all right, I know I have a point D over here somewhere, and I know I have a point E over here somewhere. So what are these midsegments going to be? And the book is going to talk about this more later, but I'm just going to go straight to it. Anytime you want the middle, well, think about it. Just worry about the x-axis. I want the middle of 0 and 2. Well, what's the middle of 0 and 2? 1 is. And I also want the middle of the y-axis. I want the middle of 0 and 6. The middle of 0 and 6 is 3. So that would be my point right here. Point D is going to be at 1, 3. That looks terrible, which is not surprising really, right? So 1, 3, and again, I get the middle of the x's and I get the middle of the y's, and that ends up being this point right here. Think about it. 0 plus 2 is 2. 2 divided by 2 is 1. 0 plus 6 is 6. 6 divided by 2 is 3. So I'm going to do the same thing in this direction. 2 plus 7 is 9. Half of 9 is 4.5. So there you go. I'm going to be at 4.5. And in this direction, I get 3 again. So 4.53 is going to be my midpoint in this direction. 4.53. So again, just to be clear on this, you're going to add up your x's, you're going to add up your y's, and then you're going to divide them by 2. That's how we're going to get the middle of these segments. So that was A. It asked us to graph it. B asked us to find D and E, which we did. C is asking us, what's the relationship? Well, the slope here is 0, the slope here is 0. So for sure, these things are definitely parallel. And then we want to know, if I double DE, will I get AC? Well, the distance here is from 1 to 4.5, so the distance here is 3.5, right? The distance here is from 0 to 7 is 7. What do I get if I double 3.5? I get 7. So yeah, 2 DEs is equal to AC, and DE is parallel to AC. We've proven both of those with coordinate geometry. And again, that's the beauty of coordinate geometry, is that we take these algebraic shapes I'm sorry, these geometric shapes, and we use algebra to prove things about them. All right, now we need to get the perimeter of both of these. So this is 3.5 and this is 7. This distance right here is 1 squared plus 3 squared. So 1 squared plus 3 squared, the square root of that will give me this. So I'll get the square root. I haven't used a shortcut yet, but I'm gonna. The square root of 1 plus 9, so the square root of 10 is 3.16. So I know that this is 3.16. Here it is 1, 2, 3, and 1, 2, 3, right? 3 by 3, so it's the square root of 18. 3 squared is 9, 3 squared is 9. So the square root of 18 is 4.24. So the small triangle, the perimeter of triangle BDE is equal to 3.16 plus 3.5 plus 4.24. So 3.16 plus 3.5 plus 4.24 is going to equal 10.9. So the perimeter here is 10.9. And now we need to do the big one, which is kind of a pain, right? This is starting to look real ugly. So what is the length of AB? Well, the length of AB is going to be 1, 2, 3, 4, 5, 6, and 2, right? So 6 squared plus 2 squared is 36 plus 4 is square root of 40. So the square root of 40 equals 6.32. So 6.32 for the big one. And then this side length is 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5. Is that 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5. So I know I screwed this one up. This is totally wrong right here. I'm going to have to fix that because I went 3 by 3, but it was actually 3 by 2.5. Ah, crap. I'll make another comment. I'm not starting this video over, I guarantee you that. So anyways, 6 squared is 36, and 5 squared is 25. So square root of 61 is going to be 7.8. So this is 7.81. So the perimeter of triangle, and again I need to fix this one because that's not right now, dang it. The perimeter of this one is 6.32 plus 7.81 plus 7. So we'll go 6.32 plus 7 plus 7.81. is going to be 21.13. So the perimeter of ABC is 21.13. Again, I need to recalculate this because it's going to be 3 squared plus 2.5 squared, which is annoying. So it's going to be the square root of 3 squared plus 2.5 squared. I didn't put the... Man, I am losing the script right now. Plus 2.5 squared. And we're going to get 3.9. So again, I'll make a note that I screwed that up. So it's going to be 3.16 plus 3.9. They could have really chosen friendlier numbers to not make this so ridiculous, but whatever. And we get a perimeter of 10.56. So the question is, what happens if I double 10.56? 10.56 times 2 equals 21.12. Hey, look, this is twice as big. The perimeter is twice as big. That would be the relationship. Well, what about the area? Well, the area of a triangle. The area of a triangle. Oh, boy. I'm really losing it here. The area of a triangle. Oh, gosh. I hope no one ever watches this video, ever. The area of a triangle equals base times height divided by 2. So this one is 3.5 times 3 divided by 2. So 3.5 times 3 divided by 2. And we get 5.25. So the area of this one, the area of triangle BDE was, I think it was 5.25, right? It's 5.25. The area of the big one is 7 times 6, right? The base is 7, and the height is 1, 2, 3, 4, 5, 6. So 7 times 6 divided by 2, which I already know is 21, but I'm going through the motions for some reason. So the area of triangle ABC is 21, and you'll notice something. It's not twice as big. What it is it's 4 times as big. And you're really going to explore this relationship in Integrated 2. But why is the perimeter 2 times as big while the area is 4 times as big? Well, here's why. Because it's growing in twice as big from left and right, and it's growing twice as big up and down, and 2 times 2 is 4. So the perimeter is only growing in one direction, so it's twice as big, but the area is growing in 2 dimensions, so it's 4 times as big. There's some interesting implications to this that I won't go into in this video, but essentially that's the way it works, and like I said, we'll save that more for Integrated 2. Man, oh man, what a mess I made of that. Alright, so we will go back to recent documents, and we are on 722A. So we did 793 and 794. So now we will look at 795. It says, as Cassie worked with Sergio. Holy crap. As Cassie and Sergio worked on problem 794, their teammate Esther had difficulty finding the midpoint of BC, and they decided to find another way. Well, I've already told you what the other A is. We're going to add the x's together and divide by 2, and we're going to add the y's together and divide by 2. So actually, they want us to do something different here. So they're saying A is going to be one endpoint. So we're going to say A is at 3, 4. That's going to be one endpoint. And then we're going to go M is 8, 11, and that's going to be the middle. And they want to know where the other endpoint is. Where should we put B? So let's go ahead, and I've jotted this down, and we're going to prove why that's going to end up being where B is going to go and why. So we will go here. I will go to the bigger coordinate plane. Again, I have some points jotted down here. So A was at 3, 4. And M was going to be at 8, 11. And what they're saying is, hey, we want M to be the midpoint. Well, where should the other endpoint be? Well, to me, it makes sense that it would be, if I had to go up 1, 2, 3, 4, 5, 6, 7, and over 1, 2, 3, 4, 5 to get to the halfway point, I should probably go up 7, 1, 2, 3, 4, 5, 6, 7, and over 1, 2, 3, 4, 5 again. So 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5. And this is where point B is going to be. And you can see B is going to be at, what is that, 13, 13, it looks like. And let's see if that makes sense to put this here. So, a couple of thoughts. That'll make sense to me if I can add 3 plus 13 and get 16 and divide by 2 and get 8. And add 4 plus 13. Oh, this is 18. What am I talking about? This is 13, 18. If I can add 4 plus 18 and get 22 and divide by 2 and get 11, and I can, and remember, that's what we're saying. To get this 8 is 3 plus 13 divided by 2. 16 divided by 2 is 8. And to get, remember, this is 18, not 13. So 4 plus 18 divided by 2, 22 divided by 2 is 11. So I have 2 screw-ups in this video I need to go back and mark. So there we go. There's our 8, 11. That's how we're going to get the midpoint. So because of that, we can use that logic and go back to this one and start getting some more of these midpoints. Boy, this is going to be a terribly long video, and I don't have notes if this is 2 days, so I don't know why this is so long. Anyway, if I go here, we have what would be the midpoint of 298? Well, 2 plus 98 divided by 2 is 100 divided by 2 is 50. So my x is 50, and my y is going to be 125 plus 15 divided by 2, or 140 divided by 2 is going to be 70. So that would be the midpoint of this. Sometimes we ask for the midpoint, sometimes we ask for the endpoint. If they ask for the endpoint, we just double it. If they ask for the midpoint, we add together and divide by 2. So let's test this method to see the midpoint of this segment. So again, my x is going to be negative 5 plus 9 divided by 2, which is 4 divided by 2, which is 2. And my y is going to be 7 plus 4 divided by 2, which would be 11 divided by 2, which is 5.5. So I would get 2, 5.5 as the middle of these 2 points. All right, we will go ahead and close this and then open up the next one to keep going here. So 796 on a map. Carey drew a set of coordinate axes. He noted that the town of Coiner is located at 3.1 and Woottonville is at 15.7. If the towns want to place a school at the midpoint, where should it be located? I could graph this, but I don't need to. The x, again, is going to be 3 plus 15 divided by 2, or 18 divided by 2 is going to be 9. The y is going to be 1 plus 7 divided by 2, or 8 divided by 2, which is 4. So 9, 4 will be the midpoint of these two towns. You can see it's kind of easy once you get going with those midpoints. All right, finally, to end this perpetually long video, and then I have to go find my errors, which sucks. Randy is studying the triangle at the right. Randy thinks that the best name for this triangle is as isosceles triangle. For this to be true, it has to have 2 equal sides. Use your algebral tools to determine if it meets these conditions. Calculate the area and perimeter. So my goodness, this is never going to end. All right, so on this one, we have a distance of 2 and 1, 2, 3, 4, 5, 6. So 2 squared plus 6 squared. So the square root of 2 squared plus 6 squared is going to be this side length. So the square root of 2 squared, which is 4, plus 6 squared, which is 36, I'm going to get 6.32. So I know that this length is 6.32. I know that this length is 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4. So it's going to be the square root of 8 squared, which is 64, plus 4 squared, which is 16. That's going to give me 8.94, so this is 8.94. And this last one is going to be 1, 2, 3, 4, 5, 6 by 2. So that does sound familiar. 2 squared is 4, 6 squared is 36, so this is 6.32. So yeah, I would definitely say this appears to be an isosceles triangle. It's an isosceles triangle because it has the same lengths. Although I guess the question would be, is this a corner? It might be an isosceles right triangle because I'm going down 6 and over 2 and up 2 and over 6. So down 6 and over 2 and up 2 and over 6. So yeah, I'm going to get a corner here. So not only is this an isosceles triangle, but it's an isosceles right triangle. So I've determined that. My perimeter is going to be adding these things together. So 6.32 plus 6.32 plus 8.94. So I'm going to get a perimeter of about 21.58. I'll put about 21.58. And then now I need to get the area. And the area is base times height divided by 2. Well, since this is a corner, this is my base and this is my height. Even though they're kind of rotated and diagonal, I still know that since I have a corner, this is my base and height. So I'll say my area is 6.32 times 6.32 divided by 2. So my area is 19.97. Or about 19.97. So there you go. A lot of coordinate geometry in this one. Not always the easiest stuff. I hope you followed this. I know I went quickly, but this is still a long video. But you have the opportunity to rewind or ask questions. So we can go from there.